In this video, we're going to look at exponential equations, and we're going to look at two different ways to solve these exponential equations. One way is this case where you can make the bases match, which is this one right here. And if that's the case, we're going to set the exponents equal to each other, because if they have the same base, then in order for the expressions to be equal, the exponents must be equal. Another way to do this is to get the exponent by itself, and then we're going to switch to log form. Or you could take the log of both sides. I think switching to log form is a little more efficient, so we'll do that in this video. So here's this first one. I'm just going to rewrite this here because these exponents are a little bit small. And you can recognize, or if you don't, you might be able to recognize that 125 is 5 cubed. So, and you can check that in your calculator if you want. So we can just rewrite this as 5 to the 2x minus 9 is equal to 5 cubed. And now we have this case where I have 5 and 5 here. So 5 raised to the power is equal to 5 raised to the power. So these must be equal. So it's not really that the bases cancel. We can just assume that they're equal, and 2x minus 9 must be equal to 3. And then solve this equation. So we'll do that quickly. We can add 9 to get 12, and then x must be 6. And here you should always check your work when you're solving an equation. So you can plug 6 back in here, use a calculator, and make sure you get 125, which you get 3. 5 cubed is 125. Okay, pause the video, try number 2. And then we'll go over number 3. So pause the video, try number 2. Here's 16 is the same as 4 squared. Oh, I didn't rewrite it, sorry about that. So we have 16 to the x power, which is 4 squared to the x power, and that's equal to 4x plus 1. So the rule for exponents is when it's up high, you multiply, or raise the power to a power, you multiply. So really that's 2x is equal to x plus 1 when we set the exponents equal to each other. And you can subtract x from both sides to get x is equal to 1. Okay, number 3, we look at this and say, well, first we have this 3 and multiplied by this. So that's going to give us something that it doesn't end this form here. So on number 3, you want to get the base and the exponent by itself. So we get the base and the exponent by itself by dividing by 3. So this is really like a lot of other problems that you've solved, or a lot of other equations you've solved, trying to get x by itself. Use those same rules. And so once the exponent is by itself, now we have this variable up in the exponent. So to bring that down, we can write this as a log. So when you write something as a log, we start with the base, and the base is 2. So we have log base 2, and then we pull the little switcheroo. We switch these, switch the sides here. So this is 33 is equal to x minus 2. And then now remember, this is all just a number. Excuse me. So this is all just a number. You can type that in your calculator you want. We'll talk about how to do that. Or you can just leave it, and that's an exact answer. But we're just going to add 2 to both sides. So this is x is equal to 2 plus log base 2 of 33. Now, depending on what type of calculator you have, it depends on how you type this in. If you hit math, if you have a TI 84, if you hit math and then scroll up or down, but up's a little faster, look for log base, and you can find this button. If you don't have that log base button somewhere on your calculator, then there's what's called the change of base formula. And real quick, what that is you take the log of what looks like the top. It's not the top, but it kind of looks like it. So we'll say that's the top of the fraction, and divide that by log of what looks like the bottom, although it's not, it's the base, but we'll divide by what looks like the bottom of the fraction. So this is how you can type this in your calculator. And if we type that in, see if we can type that in real quick. You get about 7.04, it looks like. And once again, you can check this by plugging it in here. And because you rounded, you get an approximate answer, but you can check that. Okay, now pause the video and give number 4 a shot. Okay, once again, we need to get the base by itself, so we're going to subtract 4 from both sides. And that gives me 3 to the 5x is equal to 4. And then write this as a log. So that's log base 3, pull the old switcheroo, is equal to 5x. And then divide by 5 on both sides. So x is equal to log base 3 of 4 over 5. Or you probably see it written as 1/5 log base 3 of 4. It's probably a little better way to write it, 1/5 times that. If we want to approximate that, we can, once again, use either your log base button, or if you don't have one of those, it's log 4 divided by log 3. And then divide that by 5 or multiply by 1/5. And you get about 0.25. Okay, number 5 is a little bit different of a question. Number 5, you need to recognize that this is in quadratic form. So you can think of this, and I'm going to use y just so we don't use x. Let me rewrite this. So if we think of this with y squared minus y minus 6 equals 0, if you think of that formula or that equation, we can solve this by factoring. So we can do y minus 3 and then y plus 2, because those are two numbers that multiply to -3 and add, or multiply to -6 and add to -1. Okay, well, this follows the same quadratic pattern. We have e squared, and then e to the first, there's the x there, and minus 6. So we can factor this the same way, except we have e to the x instead of y. Now we could do some kind of substitution, like y is equal to e to the x. A lot of times that confuses people a little bit more. So I would, but you can try that. Like if y is equal to e to the x, then I can substitute this for this and this here. Or just try to see the pattern. If I square this term, I get this term. If I square this term, I get this term. So there's that pattern. Okay, then we have two different equations we can solve. So that gives me e to the x minus 3 is equal to 0, and e to the x plus 2 is equal to 0. I should have moved these up here. See if I can squeeze it in outside the box here. So this is e to the x is equal to 3, and this is e to the x is equal to -2. Okay, now if it's e, our base is e, then we're going to use a natural log. So this gives me the natural log, and then we pull the old switcheroo of 3 is equal to x, or the natural log, that's my base e, of -2 is equal to x. And if you remember from your natural logs, you can't have a -2 or a negative value inside of your log function. And so this one's just thrown out because it's undefined. This doesn't make sense in math. But this guy is just a number. So this is our solution, the natural log of 3. And if we want to approximate that, we can just by typing find your ln button. So ln of 3, and you get 1.0. We'll go 97. I think I broke my rounding rules. I typed on here to round to 4 decimal places, and I did not do that. So there's the exact and then approximate answer.